So hi, this is Venkatesh. Welcome to Venki's Emerging Edge YouTube channel. So today we are mainly focused on ensemble techniques. Ensemble techniques or methods. Is it clear? Okay. So these are mainly three different types. The first one is bagging. Next one is boosting. Next one is stacking. So these three are main importance here: decreasing of variance, decreasing of bias, and maintain the high accuracy. Let's first of bagging. The best example is a random forest. Random forest algorithm. Is it clear? So that means random forest means here bagging means it is a combination of bootstrapping and aggregation. Random forest. Next boosting. These are mainly three different types. One is Adaboosting. Next one is gradient boosting. Next one is boosting. So, so gradient boosting sometimes is also called a gradient boosting mission, GBM. Is it clear? Okay. So today we are mainly focused about so how the Adaboosting technique is applied for the mathematical for a given data set. How the gradient boosting is working. Next one, what is the advantage? What are the features of boosting? This is a main topic in a today lesson. Okay. Okay. So Adaboosting. So all of you please listen. I will explain Adaboosting in the entire in maybe single word. It is very simple. Okay. In Adaboosting, what will happen? It is mainly focused on weight updation. Weight updation of each and every model, base model. Okay. For example, how the Adaboosting is going on. For example, we take the small data set. The small data set is contain maybe a 6 rows. For example, 1, 2, 3, three different other features. This is a target feature. The first one is a age. First feature is age. Second one is salary. Next one is experience. Is it clear? Okay. Age greater than equal to 50, less than 50, less than 50, greater than equal to 50. Just only we are taking the four different rows. We can easily understand about salary in maybe a dollars 80, 50, 70, 90. Is it clear? Okay. Next one experience is maybe a 5 years experience, 7 years experience, 3 years experience, and 6 years experience. Okay. Target. So generally it's a given data set. The prediction, the target is called a yes, yes, no, no. Is it clear? Now we are applying of Adaboosting for this data set. So here we need to identify the weakness on each and every model. We will update now weight. Okay. First of all, here, so how many number of features are there? A, salary, expense. These are mainly three features. It is not a feature. It is a target label. Out of the three features, which one is taken initially? For that purpose, we are using of either maybe Gini index or entropy. Is it clear? Okay. So now we are using a maybe a Gini index. So then we are find out the age first one, second salary, next experience. First one age. Next here one more important question, that is how many number of stumps are using for a Adaboosting for this data set. Then we can easily remembering how many number of pieces are there, that is equal to number of stumps only. Is clear? Stumps, STUMPS. It is also very important. This is also one of the important question. How many number of stumps are using? So number that is equal to number of features. Okay, first we are applying of age stump. So a stump, this is only a this is called a stump. Is it clear? That means here we need to update now new table for a age. That the table is contain a 4 different types of columns. The first column age, second one is product value. The third one is what is target value. Last one is weight. Is clear? So how many number of features? 4 features. Then we will rewrite all the features in a new table. Less than 50, less than 50, greater than 50. Is it clear? Okay. Here. So what about target value of A? Yes, yes, no, no. What is the weight? We don't know weight initially. So that's why how many number of rows are there? 4. So that's why 1 by 4, 1 by 4, 1 by 4, 1 by 4. Is it clear? Now we need to update the weight, and one we need to find out the predict value. The predict value we can based on only stump only. Okay. What is stump? Age. Age greater than equal to 50. So age greater than equal to 50. Then say that yes, otherwise no. This is actual stump. So based on stump, we can predict value. Okay, greater than 50, then say that yes. Less than 50, no. Less than 50, no. Greater than 50, yes. So this is the we will predict the value based on stump only. But what is target value? This is y, n. To compare the predict value and target value, both are same. That is only perfect way, perfectly calculated. That is strong learner. Which one is not equal? That is a weak learner. So here we need to find out this is a weak learner points. Is it clear? I think all of you understand which one is weak learner, which one is strong learner. The strong learner, weak learner, that is depending upon the predict value and target value. So target value is a given data set value. The predict value from a stump only. Is it clear? So here we need to calculation of a error. Okay, error. So how to calculate the error means here. So how many number of correct values that will be taken as a 0? In case of 4, 4 into 0, 0. So how many values of wrong, that is mismatch, that is equal to 1. So that's a total 2. 2 into 1 into what individual weight? 1 by 4. What is the value? 1 by 2. 2 1s are 2 2. So 1 by 2 means 0.5 is error. Then we need to find out the error rate. Error rate. Is it clear? So what is error rate? How the calculation error? 1 by 2 into ln of 1 minus error by error. Is the formula. That means 1 by 2 into ln of 1 minus 0.5 by 0.5. Then you calculate, for example, you get some value 0.32. For example, I am not in here, I am not calculated. Just we taking some value equal to 0.32. Is it clear? Okay. Then you get a error rate. This is also very, very important. So very, very important for error rate. Okay. Now, so here error rate is there. Then we calculate the strong value. The strong value means we can calculate the Z value. Okay. Okay. So now we calculate the Z value. How to calculate Z value means number of correct instances into weight into e power. It is a correct, that's why taken as e power minus error plus number of incorrect instances into weight into e power 0.2 error. Is it clear? Then we apply the mathematically number. Okay, so here number of correct. So how many correct instances? You see first and second, only 2. So 2 into weight. What is the weight? 1 by 4 into e power minus error. What is the error? 0.32. So minus 0.32 plus. So how many number of incorrect? This is incorrect. This is incorrect. So 2. Again 2 into what is the weight? 1 by 4 into e power 0.2. So 0.32. Is it clear or not? Clear? Then we get some value. For example, this is finally get a 0.123. For example, this is Z value. Is it clear? Then now we need to update the weight. How to update? For example, for correct For correct values, they update the weight weight into weight into number of instances. Sorry, weight into e power correct. So that's a minus error by z value. So then what is the weight? 1 by 4 into e power error rate 0.32 minus by what is the 0.123. For example, 0.001. For example, this is only correct. So which one is correct? This is correct. So we need to update now 1.4 with a 0.001. 0.001. Next one. So one more correct. Which one is correct? This one is correct. So 1.1 by 4 is updated with a 0.001. Is it clear? Then we need to update now the incorrect values. So how can you come to incorrect values? Check it here. For incorrect. For incorrect. Then what is the formula? Weight into e power 0.2 error by z value. So weight means 1 by 4 into e power error. What is error? 0.32. So 0.325. What is z value? What is z value? 0.123. So 0.123. Then add for example here minus 0.12 only. For example. Then so minus 0.12 for incorrect. What which one it is incorrect? It can update with a 0 minus 0.12. And this is also incorrect. So it is update with a minus 0.12. Is it clear? It is a one table for a one age. Like that we create a salary. Like that we create a salary. So for example, we create a new table of salary. What is the field? Salary is one of the field. Salary. Next one is a product value. Next one is a target value. Next one is a weight. Initially age we are taking the values 1 by 4 only. We don't know weight. But in the next one salary we know that weight. Which one weight? The age, salary, weight, new updates are taken input for a salary. So that's why what is these weights are updated 0.001 minus 0.12 0.001 minus 0.12. What is the salary? Salary is given here. What is the value? $80, $50, $70, $90. So what are target values? Yes, yes, no, no. Then we need to find out the salary stump. What is salary stump? Salary stump equal to, for example, here what is given? So gather. So 80. In case of 80 salary, then we say that S only. Otherwise, no. So 80, yes. 50, no. 70, no. 90, no. Then we again compare these two values. Then we compare two values. So this is a correct value, correct prediction, correct. But is it wrong? So one is wrong. Again we calculate the error. Again we calculate the z value. Again we calculate the for correct, for incorrect, weight the updation of weight. Again this table weight are taken as for a experience. Like that we will calculate now all the features of a error value, z value, and correct weight and incorrect weight. Okay. Okay. So now we know that a age new table, a salary new table, next one experience new table. Then create a redraw a new table for a including all the features. For example, this is a age feature. Age. Next one is a salary. Next one is a experience. Finally, target value. We know that what is age error rate? Error rate is equal to 0.132. First to calculate the error rate. Like that, what is error rate of salary? Equal to, for example, 0.01. The experience error rate equal to 0.001. Is it clear? Okay. Then we know what are the values of age. That means age we taking the values of this is the target value, but based on age stump we calculate the some values. So those values, for example, check it here, age. So age stump age term, we are taking the greater than equal to 50, less than equal to 50. Greater than equal to 50, you can say that A. Otherwise, no. That was this is a yes, this is a no, no, yes. We are already created new table of age. So that's why these values y, n, and y, these values can be update in a new table. That is a yes, no, no, yes. Is it clear? Like that salary also. Salary greater than equal to 80, yes, otherwise no. That's why first one is yes, last one is yes, remaining as no. Next experience. The experience taken as a greater than equal to 5, that is a yes, otherwise no. So first one yes, yes, no, yes. Is it clear? So how to get these values? These values from a individual tables of age, salary, experience based on stump only. Okay, then calculate the target new values. So first one, sir, how to calculate these values? These are also very important. So how to calculate these values means, check it here. Here first one is y. Y is considered like a 1. No is considered like a 0. Y equal to 1, no equal to 0. Is it clear? That means y equal to 1. 1 into, what is the error rate? 0.132 plus, next one is 1. 1 into, what is the error rate? 0.01 plus, next one y. 1 into, what is the error rate? 0.001. What is the value? For example, here value 0.0003. Then that value can be updated 0.0003. Is it clear? Next one. So next value. So age 1. So n is 0. 0 into 0.132 plus again n is 0. 0 into 0.01 plus next again y. So 1 into 0.001. Is it clear? So then this value, for example, this value is 0.01. Then 0.01. Like that, we can note these all the values. This value is 0. This value is something 0.03. Is it clear? Now we will predict the new values. How can we predict the values? Means which values greater than equal to 0? Which values greater than equal to 0? Sorry, greater than 0. Sorry, greater than 0. Those are like a yes only. Otherwise, no only. This is a new prediction value. This is a final output. This is called a Adaboosting. Thank you.